Okay, so far we have seen exploratory techniques, visualizations, feature data types, number of observations, number of features, and we have learned a lot about these types. And now it's the time, and after gathering enough information, now it's the time to clean the data, which now represents that we're moving towards the preparation of data for the machine learning algorithm. So the first step for that is data cleaning. Data cleaning is very important because a better data gives us a good chances of success. And when we're talking about good data or data cleaning, is what I mean is that a data has a lot of features and a lot of values that are not going to help in training the machine learning algorithm, but actually it's going to have a negative impact on the training. It's going to decrease the accuracy. To give a better example of that is, let's imagine you have a feature, as we saw earlier, a particular feature of basement, and it had only one value with a very high frequency. And it was quite clear, and you don't even need a multivariate visualization or a correlation matrix to tell us that that variable has no contribution to the price of the dataset of the house, and it would have no impact on the training as well. And these types of features are not going to help us, but actually mess up the entire training process. The other example of this would be missing values. When we were looking at the Titanic survival dataset, we saw that there were a lot of missing values in many features all across the data. These missing values mean that there is a lack of information. These are actually gaps that need to be filled before we train a machine learning algorithm. Otherwise, they will cause a lot of problems. So that's why it's very important to clean the data before feeding it to the machine learning algorithm. Otherwise, it will have a lot of negative impact, and these missing values and poor features will ultimately decrease the accuracy of the predictions in the end and not let the machine learning algorithm learn at its best. Across many datasets, you will see that there are a lot of duplicate values and irrelevant observations. They can occur in any dataset. But the problem is that they will cause a lot of imbalancing and leading to an imbalanced dataset. An imbalanced dataset means that you do not have equal information to support both claims. For example, if you're talking about a classification problem and you have about 100 images of cats and dogs, in order to have a good accuracy of evaluation and have a better training accuracy and better predictions, you need to have about 50 images of dogs and 50 images of cats, so that now you have equal information to present both scenarios. But these duplicates cause imbalancing in the dataset, which lead to a biased answer. So if you have an imbalanced dataset, it will mean that most of the times if you show an image of a cat, the algorithm will tell you that it's a dog because the algorithm saw more images of dogs as compared to cats. So it will give you a biased answer. Irrelevant observations are features that are not required to model the problem. And these were the features that have very low correlation with the target value. And we can find these out and weed them out using the correlation matrix and ultimately help us get a better chance and to model the problem. For example, in the house prediction dataset, the names of the owners don't have much value. So even if you don't add them in the model, the machine learning algorithm or the price of the house will not be affected by it. So duplicates and irrelevant observations are one of the reasons we need data cleaning, and we need to remove them. So duplicates and irrelevant observations are one of the reasons we need data cleaning, and we need to remove these duplicate values and those irrelevant features that are not contributing to the target value. The next ones we have the mislabeled classes. You remember when we talked about the categorical visualization of features? And I said that in order to better understand it, we need to understand data cleaning. So data cleaning is where we can understand the importance of categorical feature visualizations, because we can now understand and identify the mislabeled classes. The mislabeled classes are represented into many different ways. One of the ways is that most of the classes are actually the same feature. For example, in the roof feature, we have shake shingle, and asphalt and shake shingle. They are actually the same feature, but they have different names for them. different names, but actually they're the same feature. And we can find them out using the visualization of categorical values, because in this way we can understand that these have the same count and they are actually the same feature. So you need to merge them together, or maybe exclude or delete two of them and keep only one, because their other ones are just duplicates or mislabeled classes of the same type. And there are other same features as well, for example asphalt and composition. Only the first capitalization of the letter does not mean that they're different, they are the same feature. So we need to merge them or remove them, but either way they're considered to be duplicates and they're just causing imbalancing in the data, so they need to be removed. So mislabeled classes are actually one way of identifying the duplicates in feature. After we can have removed the duplicate classes, we get a much finer and better representation of the values of in this feature. Now we can understand that the imbalancing or the noise has been removed from it. So the third thing is, and I think the most challenging part, is to deal with the missing values of the data. As I said before, missing values represent missing information, and it's always a challenge to fill in these gaps, to fill in that information, but at the same time you cannot be biased with it, because this is the moment where human intervention can also cause a lot of problems during training and maybe introduce a lot of bias in it. So we usually have two types of options when we're dealing with missing data. We have an option of dropping those values. What we mean by dropping is that we completely ignore them and remove them from the dataset. And the imputation is the one in which we calculate the mean value. So we have two techniques we can use to deal with missing data values. One of them is dropping and completely removing that missing values, but it would also mean that you might be removing a lot of important information. So the other technique is imputation, which does is that we take the mean of all the other values and replace those missing values with the mean of all the other values. So this is a good technique, but again, we don't know which of the techniques we should use, because either of them can introduce a human bias. And most of the time, it's a very difficult decision to deal with missing data values. So what data scientists do is that they try both of the values and see which of them works. Although it is a time-consuming process, and sometimes it may take more time, but there is no shortcut to this. Sometimes it takes them years and years of research, or maybe they work on a problem, keep on working on it. Sometimes domain knowledge helps them, sometimes maybe some other technique. Maybe they use the knowledge and information of some other data scientist who has worked on a similar problem, or maybe they read the research of someone else and then decide that, okay, maybe this is the best technique. So there are many other ways they can do it, and it really depends on a person's experience to do that.